What if I told you that everything you think you know about the beginning of the universe might be completely wrong? The Big Bang wasn't necessarily a beginning at all, but possibly just another moment in an eternal cosmic dance that has been playing out for far longer than we ever imagined. For decades, we've been comfortable with the idea that our universe exploded into existence 13.8 billion years ago from a single point of infinite density called a singularity. But here's the shocking truth that's keeping cosmologists awake at night. The Big Bang theory doesn't actually tell us what came before. It's like having a movie that starts in the middle of the action and pretending the opening credits don't exist. Think about it this way. We know the universe has been expanding and cooling for billions of years, but when physicists try to trace everything backward to that initial moment, something extraordinary happens. All our equations break down. Our laws of physics stop making sense. It's as if the universe is holding up a giant cosmic stop sign that says, "You shall not pass." This isn't just an academic puzzle. Recent observations have revealed something that's shaking the very foundations of cosmology. The universe isn't just expanding, it's expanding faster and faster. Something is pushing space itself apart with incredible force, and we have no idea what it is. This discovery has forced scientists to reconsider everything we thought we knew about cosmic origins. Let me share with you the most mind-bending possibility that's emerging from cutting-edge physics. What if gravity, the force that keeps your feet on the ground and holds planets in orbit, could actually work in reverse? Einstein's equations suggest that under certain conditions, gravity doesn't just pull things together, it can push them apart with tremendous force. Imagine the early universe filled with a special kind of energy field, spread uniformly throughout space. Unlike the rocky objects we're familiar with that create attractive gravity, this energy field would generate repulsive gravity. The result would be explosive expansion, pushing everything outward at incredible speeds. This repulsive gravity might have been the real engine behind the Big Bang, turning it from a mysterious explosion into a natural consequence of physics we're only beginning to understand. But this revelation opens up an even more staggering possibility. If the Big Bang was driven by repulsive gravity from an energy field, where did that energy come from? This question has led scientists to propose something that sounds like science fiction, but might be scientific fact. Our universe could be part of an infinite cycle of creation and destruction. Picture this scenario. Our expanding universe eventually reaches a maximum size and begins contracting, pulled back together by gravity until everything collapses into another singularity. But instead of ending there, the compression creates the conditions for another explosive expansion, another Big Bang, giving birth to a completely new universe. This process could repeat endlessly, with each cycle lasting trillions of years. Albert Einstein himself considered this cyclical model as an alternative to a universe that simply began and will end. The idea is both beautiful and terrifying. Beautiful because it suggests the cosmos is eternal, with no true beginning or end. Terrifying because it implies that everything we know, everyone we love, and every achievement of human civilization is just one brief chapter in an infinite book of cosmic history. However, this cyclical model faces a serious challenge rooted in one of the most fundamental laws of physics. Entropy always increases. Think of entropy as cosmic disorder or waste heat. Each time the universe goes through a cycle of expansion and contraction, it accumulates more disorder. This means each new cycle would be longer and more chaotic than the last, eventually making the cycles so different from each other that the model breaks down. Recent research has cast even more doubt on cyclical models. Scientists studying various bouncing universe theories have found that they might not work as elegantly as once hoped. Instead of providing an escape from the question of cosmic origins, these models seem to push the beginning back, but not eliminate it entirely. Hey everyone, thanks for stopping by. If you enjoy the content we shared today, don't forget to hit that subscribe button. This brings us to one of the most radical proposals in modern cosmology, suggested by physicist Stephen Hawking. What if the question, what came before the Big Bang, is fundamentally meaningless? Hawking proposed that time itself began with the Big Bang. Before that moment, there was no before, because time didn't exist. According to this view, if you could somehow travel backward through time approaching the Big Bang, something extraordinary would happen near the beginning. Time would gradually transform into space until there's only space and no time at all. It's like asking what's north of the North Pole, a question that seems reasonable but has no meaningful answer because you can't go further north once you reach the northernmost point on Earth. But perhaps the most mind-expanding possibility comes from multiverse theories. These suggest that our entire observable universe, with its hundreds of billions of galaxies, might be just one bubble in an infinite cosmic foam. Beyond the edge of our cosmic horizon could exist countless other universes, each with its own laws of physics, its own history, and its own destiny. Some of these parallel universes might be almost identical to ours, with versions of Earth where history unfolded slightly differently. Others could be so alien that matter, energy, and even the concept of existence work in ways we cannot imagine. This multiverse concept doesn't just explain what came before our Big Bang, it suggests that the question itself is too narrow. Instead of one universe with one beginning, we might be dealing with an infinite collection of universes, each with its own origin story. Recent theoretical work has pushed this idea even further, suggesting that universes might not exist in isolation but could actually interact with each other. Some models propose that our expanding universe is growing by merging with newborn baby universes, like a cosmic organism that feeds and grows by absorbing its offspring. This creates a picture of reality where universes give birth to each other, merge, and evolve in a complex web of cosmic relationships. The implications are staggering. If these theories are correct, the fabric of our universe might be woven from threads of other cosmic realms. Every atom in your body, every star in the sky, every galaxy we observe could be the result of ancient cosmic mergers that occurred before our universe even began its current phase of expansion. What makes this even more fascinating is that some versions of multiverse theory suggest that all possible universes exist simultaneously. There could be universes where the laws of physics are slightly different, making stars burn longer or shorter, planets form more easily or not at all, and life evolve in ways we've never considered. In some of these universes, different versions of human civilization might have developed technologies that seem impossible to us, while in others, life might never have emerged at all. This brings us to one of the most profound questions in all of science. Why do the physical constants in our universe seem perfectly tuned for the existence of complexity and life? The strength of gravity, the mass of electrons, the rate of cosmic expansion, all appear to be set to precisely the right values to allow for the formation of atoms, stars, planets, and ultimately, living beings. Multiverse theory offers an elegant explanation. Perhaps we live in one of countless universes where the constants just happen to have the right values for life. In most other universes, the conditions might be completely hostile to any form of complexity, but we can only exist in, and therefore only observe, the rare universes where everything works out just right. As we stand at this crossroads of scientific understanding, peering into the deepest mysteries of existence, one thing becomes clear. The question of what came before the Big Bang has led us to possibilities far more extraordinary than anyone could have imagined just a few decades ago. Whether our universe is part of an eternal cycle, one bubble in an infinite multiverse, or something else entirely, The journey to understand our cosmic origins continues to reveal that reality might be far stranger and more wonderful than we ever dared to dream. The next time you look up at the night sky, remember that you might be seeing the light from just one tiny corner of an unimaginably vast cosmic story that has been unfolding for eternity, with chapters yet to be written and mysteries yet to be solved.